You're listening to Data Center Therapy. Please take a number, and an engineer will be right with you. Hello, everybody, and welcome to another episode of Data Center Therapy. I am your host, Matt Yette, and we have a special treat for you all today. If you've been listening to this podcast and you're familiar with Ivoxy Consulting, you certainly know the gentleman I'm about to introduce. But if you're new, you are in for a treat. Joining me today is our very own Alec Taylor, a co-founder of Ivoxy Consulting. Alec, how are you?
Matt, I'm doing awesome. How are you doing today?
Great, thank you. And I'm finally seeing some sunshine breaking through here early in the day, and I don't have to wait until 7 or 8 o'clock when it's nearly my bedtime.
Well, send some down to Olympia. We haven't had sunshine in what feels like about a week now. So,
you know what I'll send down to you? I'll send down that 4.7 earthquake that woke me up at 3 o'clock this morning.
Whoa, you had an earthquake?
Yeah, I did. That was the third I've ever felt in my life. But due to the power of technology, Twitter and Facebook, I was able to go online at 3 o'clock in the morning looking at my bright phone and say, was that what I thought it just was? It woke my dog up. It woke me up. My wife, dead asleep.
Wow.
But yeah. It felt like somebody slid my bed into the wall. That's because it woke me, of course. But yeah, not very. Earthquakes are not uncommon up here, but actually feeling them are. So.
Well, my daughter Bailey was in both of those LA earthquakes that hit last week, and she said that it was pretty scary. So.
Oh yeah. Of course, it's also a different vibe to people who are used to it on a more regular basis, where they would probably be laughing at us right now.
Right.
But I'm glad that she's safe anyway.
My gosh. Well,
yeah.
All right. Well, glad you're safe as well, Mr. Yette. We can't have this podcast without you, so.
Alec, tell us, for those who don't know you, tell us a bit about yourself, would you please?
Yeah, you got it. So this is my 26th year working in information technology, and the 13th year since Eric and I founded Ivoxy Consulting. And I've been working with, our topic today is related to VMware. So I've been working with VMware since probably first time I touched it, maybe 2004 time frame, and working seriously as a consultant, doing all things related to virtualization since 2006. So a little like yourself, been working on this platform for a little while.
Yeah, and you are also the face of a lot of our road shows and our workshops that we do, where you really deep dive into these kind of topics, such as VMware performance. So we should be well warmed up. And if you want to check out some of those workshops, of course, hit us at the email that we announce at the end of the show, and we can fill you in on where Alec will be next if you want to hear him talk. But have a feeling after this episode, if you weren't already fans of the Alec Taylor show, you're going to be converts, and we'll let you know where you can buy tickets at the end. No, I'm just kidding. There's no tickets.
Well, you
don't sell tickets,
many of the people. Well, I can if you want to throw money at me. Many of the people who have come to our workshops have said, Alec, you have got a face for a podcast, and I thought, you know what, I'm flattered. So why not do the podcast thing? So.
I like it. Well, I like this topic that we're talking about today, Alec, which is VM performance. And the reason I like it is because I think it's one of those topics that we did the deep dive years ago. And what we think we might know, we think is like, oh, that's been solved. That's not anything new. We can move on because that's just assumed magic now. It's not the case, right? We've had updates. We've had changes to how CPU cores and NUMA, etc., are handled, hypervisor scheduling. So give us a broad strokes, and then we'll kind of dive into the topics on what's new with VM performance in a hypervisor land.
Yeah, absolutely. So specifically, we'll talk about NUMA today, but with the release of vSphere 6.5, VMware made some significant changes under the covers to the way that NUMA and virtual NUMA are handled. So much so that if there are folks out there running on vSphere 6 and are looking for reasons to move to 6.5 or 6.7, one of them is certainly enhancements that have been made to NUMA that can very drastically affect the performance of a virtual machine. Broad strokes, however, are that with everything VMware, resource management does matter. Common issues that we see are virtual machines that are over-provisioned for CPU, over-provisioned for memory, or not optimally configuring virtual machines, taking into account the physical resources and those configurations, and I'm talking specifically NUMA architecture of the underlying hardware that's running those virtual machines. Additionally, we find there are many customers out there that run VMs that are latency sensitive. Specifically, think online transactional databases. Think about virtual machines that might be in the call path of a VoIP or a media call, right? Virtual machines where we're not sending a lot of data over the network or a lot of data over the virtual SCSI connection, but the time that it takes for that transaction to complete matters a lot. So if folks have questions about what is this workload latency sensitive or not latency sensitive, reach out to us at with the contact information that you'll get at the end of the podcast, and we'll be happy to help you figure that out. But we're going to talk about that as well, and a little bit about how the hypervisor manages those resources so we can help our virtual infrastructure perform at its best, and we're not making configuration decisions that fly in the face of some of these best practices.
Sure. I mean, we've all seen people with domain controllers with 8 cores and 16 gigs of RAM, and says, "Oh, what's the big deal? It's all shared, right?"
Right.
That's for VMware to figure out.
It's free. Yes.
And why is my co-stop at 20 milliseconds or 100 milliseconds? Yeah.
Yeah, that's exactly right.
Give me some update on the NUMA changes that have been made here.
Well, the big thing, starting with vSphere 6.5, is that the hypervisor no longer takes CPU configurations into account when performing NUMA placement. So effectively, VMware has made the CPU scheduling portion of the show a lot less rigid and complex than it was in 6.0 and previous versions, allowing the hypervisor to more efficiently use the physical underlying hardware than in previous versions. There's a very detailed write-up on those changes at Frank Dinneman's website. Many VMware aficionados will be familiar with Frank. Where would we be without him?
Mm-hmm.
And he goes into great detail about how the hypervisor performed NUMA scheduling and passing NUMA architecture through to virtual machines in 6.0 and before, and then in 6.5 and later. So if you haven't been to Frank's site, it's Frank, Frank, D as in dog, ENNEEMAN, Frank Dinneman, I believe it's .net. And you can read about that in some more detail.
Yeah, it's scary looking at this punch list that we want to talk about when it comes to VMware performance, because this can be a 30-hour episode, let alone 30 minutes. So we're definitely skimming the surface a little bit on some of these things, because like you said, they are such deep topics and very scientific when it comes down to it in the scheduling.
Yeah.
Matt,
real quick. So just to verify, it's frankdinneman.nl. He's in the Netherlands, so it's
okay.
.n is in Nancy and .l is in Larry, not .net.
Frank Dinneman from Gary, Indiana, is now excited because he sent that initial traffic his way.
You can see pictures of his dog.
That.
Exactly. You got
it. And you can control his Christmas lights
right,
in December.
Exactly. All I saw was a picture of a coffee machine with an Ethernet cable, and I clicked on it. Made a pot of coffee.
One of the big questions I get from everybody is, Matt, do I want to set my VMs to have 2 sockets or 2 cores when you're talking about vCPU configuration?
Yeah.
What is the deal there?
Well, it does matter. And
did it not matter at some point?
Well, I guess prior to some of the Well, prior older versions of vSphere, we did not have the ability in the user interface to do multi-core virtual machine configurations. And when those features came out, and it's been a long time since those came out, I got to say 4X days that those were made available to us. VMware pitched it. Why is this feature here? Well, this feature is here in case you're running an operating system or an application that is licensed by socket or by core, so that you can give, let's say you're running Windows Server Standard Edition that puts constraints on how many CPUs that it will support. You can give a virtual machine one socket, multiple virtual cores, and then you're not paying for a 4-core or a 4-socket or an 8-socket server, quote unquote server. You could give it executable threads just like a physical CPU would have.
And from what I understand, at least in the early stages, performance-wise, that was more or less a wash. And then I've read some things that say unless the application is specifically designed to take advantage
yeah,
of a core versus a socket,
right. It's
but
kind of
by
murky.
and large, the rule of thumb was they're more or less the same. At least that's what I understood.
That's correct. We
Okay.
talked about them as if they were missive, and the reality is that was not true. So the question is, why would I build a virtual machine with more than one vCore? And we do see folks who have VMs configured that way, one virtual socket, 4 virtual cores. What's the deal? What is the rule? And this is where things get a bit murky, and we're going to try to clarify those things. So let's take, for example, just a very simple physical server configuration. We have an ESXi host with 2 physical CPU sockets and 8 logical cores. Hyperthreading's turned on. 8 logical cores. And let's say this server has 128 gigs of physical memory. Now, the first thing that we want to make sure of is that in the BIOS of that host, we have NUMA enabled. Sometimes in the BIOS it says interleaved or non-interleaved memory. Heaven forbid they call it NUMA and non-NUMA. So if that were the case, then we want to choose the non-interleaved choice to turn non-uniform memory architecture on. And then what that means...
So that way CPUs aren't stretching across the bus.
That way we don't have 50% of our memory is going to be assigned to CPU 1. Well, let's just let's put it this way. If we have a virtual machine configured to run on a virtual machine built to run on a system that is using a non-NUMA architecture, then we can pretty much give up on memory locality. So what we're trying to avoid is a virtual machine that is using memory on CPU A and CPU B at all. That would be preferred. If we're using interleaved memory, then 50% of its memory is going to be on one, 50 on the other, and we're going to have performance issues because if that virtual machine is being scheduled against CPU A and it has to touch memory on CPU B, there's going to be a performance penalty of going across, and we're just going to use Intel terminology since that's what most people are running, the Quick Path Interconnect, or QPI path. And we don't get to leverage certain caching functions of the CPU for non-local memory. That interconnect is much like the 405 during rush hour traffic. It has limited lanes, right? Everyone will know that analogy up here in the Pacific Northwest. We're going to run out of lanes, and we're also going to run out of capacity. And there can be significant memory performance degradation when we traverse that QPI. So first and foremost...
So we have a recommended maximum size for a VM then,
we do.
Basically by way of the hardware that the VM's running on.
So the second thing we want to make sure of is that NUMA's turned on, and the other thing we want to ensure is that half of the physical server's memory has been assigned to CPU A and half to CPU B. We have seen some folks get servers shipped from their vendor that does not have the DIMMs installed in the correct slots, which is a little bit frightening. So the system will not give you a warning that you have got 2 more DIMMs assigned to CPU A than you need to have. You want those 2 assigned to CPU B. There's no technical problem with doing that. But if you don't inventory what DIMMs are in what slots, you may find that whoever installed the memory may have not installed them in the appropriate slots. So let's say, again, in this example, 128 gigs of RAM for the server. There might be 96 gigs of RAM assigned to one CPU and 32 to the other. And that assignment is all about physical DIMM slot location. It's not a software choice or a firmware choice. It's where those DIMMs are physically installed. So that's something that I would check, so we don't find out that, vendor X, the person assembling the server that day, had not had their coffee yet and was not putting DIMMs in the appropriate place for performance. So we want to see 50% of those DIMMs assigned to one socket, 50% assigned to another with the physical slots that they're located in, and we want NUMA enabled, or choose the non-interleaved memory option in the BIOS of that server.
Is that typically a default setting in most server vendors' BIOS?
Boy,
Best to
I would
check.
say
I'm guessing
best
that,
to
that's what that
check.
means.
I would say anymore, I see less and less servers that choose kind of these legacy mode configurations, like an old operating system that doesn't support NUMA, like who's running something like Server 2000, but it happens. And the whole reason
Sure.
why that configuration is the way that it is, or why that option exists, is because there are people who are still running old operating systems that that don't support NUMA, so that is why that other option exists.
So let's use some numbers for an example. Let's say I've got a server with 128 gigs of RAM
Mm-hmm.
properly installed, so it's 64 on each side, and it's a dual socket machine. And
Yeah,
let's say it is, let's make our numbers easy. Let's say it's a 4-core. Each CPU is 4 cores,
sure.
right? What would be your configuration maximum in terms of best practice and performance for any VM running on that server?
So the hard rule is that if the virtual machine needs more memory than any one of those CPUs is controlling, then we need to enable vNUMA on the VM, and we need to make the virtual machine a multi-V core VM.
Not vCPU, or it doesn't matter?
Well, yeah, it does. It does matter. So yeah, so
At least this is clear and not confusing at all.
it's a little funky. So what we want to do, so VMware, starting with the version 6.5 of the hypervisor, says we no longer take into account CPU configurations on a virtual machine to determine how NUMA behaves, which is a smart move for all of the things folks can read about at frankdenneman.nl. But the first hard and fast rule is, if we build a VM that has more than, in this case, 64 gigs of memory, and the first question would be, does this virtual machine really, 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 really need 64 gigs of RAM? And we're going to assume in this case that it does. So let's say this VM needs 96 gigs of RAM. Then what we need to ensure is that when we configure the virtual CPUs of this VM, that we make it a 2 vCPU VM. So the number of vCPUs the VM has should never exceed the number of physical sockets that is installed in that system. Meaning we
Right.
do
So
not.
basically, you're telling the VM, hey, I'm going to spill over across
Well,
that boundary.
yeah, preferably that's the case. Or if we do, we need to ensure that the virtual machine's vCPUs can be appropriately scheduled against the number of physical sockets that we have in that system. We don't want to come up with some wacky number, like we're going to give it 3 vCPUs and 2 vCores per CPU. We don't want to give it a virtual CPU that could not be scheduled against the real physical underlying hardware. We need to make that virtual NUMA configuration align with the physical architecture of the server under the covers. So I would
And we're
make
not
that
just talking about sockets, right? We're allowed to include physical cores, right?
correct.
Okay.
So in this case, if I had to build a VM with 96 gigs of RAM and this VM needed 4 vCPUs, then I would create 2 virtual CPUs, each with 2 vCores, ensure vNUMA is turned on for that virtual machine, and then give it its
96
96
gigs, right?
gigs of RAM. Exactly. And then that way, the guest operating system is going to see a NUMA architecture that plays well with the underlying physical architecture. It mirrors the CPU count to the socket count. We've got a 2-socket server, which in this case is going to mean we have two NUMA nodes or NUMA cells, which is just a kind of a memory controller and an amount of
Hmm.
RAM, the memory controller being built into the CPU. And that virtual machine will be scheduled optimally. What we don't want to build is an 8 vCPU VM with 1 vCore per CPU.
Right. Just like the VM gets the clock speed of the actual physical CPU it's running on, uh, that's a truth that gets handed up. You wouldn't want to lie about the amount of sockets that
No,
are actually in the underlying server hardware.
no, we don't. That's where we're going to get into trouble, is that the hypervisor has to schedule the CPU resources that we give the virtual machine against real underlying physical sockets and cores. So in this case, we have a virtual machine with the same number of vCPUs that the physical system has, and then however many cores we need to meet the desired number, in this case 8. Now, hopefully we're not configuring virtual machines that have more, trying to configure a VM that has more vCPU slash vCores than the system has, because that simply won't be scheduled. That's not something we can oversubscribe memory that way, but the hypervisor will not allow us to build a VM with such a configuration. So that's going to be a hard limit, like it's always been a hard limit. But we don't want to build a virtual machine that has 1 virtual CPU and 8 vCores in this configuration, because we're going to have memory that straddles both of those CPUs, because 96 gigs of RAM is more than any of either of those 2 NUMA nodes has memory-wise. Each NUMA node has 64 gigs of RAM, no more than that. So because we're doing 96, that VM it must become a 2 virtual CPU VM. And then we add the appropriate amount of vCores to get to our number. In this case, whoever's asked for this VM has said we need 8 CPUs for this VM. And that would be the
So
config exercise for that request.
that makes a ton of sense. So let's play devil's advocate and say
Yeah.
we've got a properly configured VM. You've
Mm-hmm.
got vNUMA enabled. You've
Yes.
got two vCPUs and 4 cores
Mm-hmm.
for each one of those on the VM,
Yeah.
and you've got 96 gigs of RAM assigned. So you've got a properly configured and sized VM for this environment. Go in and uncheck vNUMA. Will it let me do that? And if so, what is the potential detriment, downside of that?
Yeah. It will let you disable vNUMA. To my knowledge, that is that is going to cause problems. I don't believe the hypervisor is going to determine, without that vNUMA option configured, that virtual machine needs to have the NUMA architecture of the underlying hardware pass through to it.
So we're talking potentially just probably just VM performance issues,
Big
maybe.
time. Yes.
Yeah,
Because
yeah.
our operating system is now participating in NUMA. So we're saying, hey, Windows, hey, Linux, this quote unquote hardware that you're running on has 2 NUMA cells. So when you're making a decision about where memory is located, where you're choosing to put memory so that any process you're running, so let's say it's SQL Server or Oracle, that the process and the memory that it's using stay local to a NUMA node, to keep us from having to go across that QPI to go access a memory
Hmm.
page. And so here is where our guest operating system ultimately makes the right, smart, optimal decision about memory placement, because we are feeding it NUMA information just like it would be getting if it were running on that bare metal with NUMA turned on in the BIOS. And if
So you're potentially reaching across that
oh
QPI
yeah,
when ideally you're coming straight up from each CPU. You're not leveraging that interconnect unless you absolutely have to.
correct,
And when you disable vNUMA, you're probably using that
correct.
interlane a lot more inefficiently and unnecessarily.
Yeah, that's the way it's been with the hypervisor for a long time, and I know of no changes when this update to 6.5 happened that would allow us to build virtual machines without ticking that vNUMA box.
Hmm.
Um, and the point here is that when a virtual machine has more than one virtual core, then the way that that virtual machine gets scheduled is that those V cores are bound to one of the physical CPUs of the system. And that's why we don't want to use, the flip side of this is we don't want to use V cores when we don't have NUMA requirements. So if this virtual machine needed 32 gigs of RAM and 8 CPUs, your best choice would be to configure that virtual machine with 8 virtual CPUs.
Interesting.
Now, there
Interesting.
was a
Yeah,
big,
that's
yeah,
definitely the rub right there because that goes against the what I thought was the rule of thumb from our previous stage of this conversation. But yeah, it definitely takes a different turn if you're within one single CPU.
but
So that
here,
in that case, you're okay to lie about the underlying hardware then more or less.
well, yeah, according to VMware with 6.5, some of the rigid constraints around giving a virtual machine multiple vCores have been relaxed. I still feel like building that virtual machine with 8 virtual CPUs rather than any configuration of cores, is your better choice. However, what VMware is telling us with 6.5 and newer is it is not looking at that vCPU configuration to make NUMA placement decisions anymore.
I
So it
see.
should be the case that our old guidance of definitely don't give a virtual machine multiple vCores if it doesn't need it, because that's going to bind the VM to an individual socket when we don't necessarily want that. This is more than just an innocuous setting. I haven't run any benchmarks 6.5 and later on the difference in like a CPU and memory bound job, like a software compile job with a VM that fits inside one of those NUMA nodes memory wise, but has different vCPU versus vCore configurations. But according to the documentation, 6.5 and newer, it actually should not matter if we give a virtual machine multiple vCores, as long as we don't give it more vCores than any CPU in the system actually has.
Yeah, and that's one of those difficult things to benchmark too, like you said, because if you just have one VM misconfigured, it doesn't necessarily manifest in any kind of tangible
Yeah, you might
in
not know it.
real world,
Yeah,
right?
yeah, yeah.
Right. It's that cumulative worry that you've got a number of the second you start to over provision a number of VMs, then it's almost like a broadcast storm, right? Where it just kind of builds upon itself, and before you know it, everything's sitting in the queue and not really getting executed as it waits for availability in the
Yeah.
scheduler.
Yes.
Um, while before we wrap up, Alec, I wanted to kind of touch on one thing um, before we go. I did want to say that these are the things that we have engineering day monthly for. And internally at Ivoxy, what we'll do is the engineers have a roundtable. We kind of just kick around the latest stuff, and we update our processes and our greater knowledge base, our data lake, so to speak, where we say, okay, we've got our vSphere assessment, right? Let's come in and do a health check.
Yep.
These are the kind of things that we read and we research and we practice in our lab, so we can update and say, oh, you're running 6.0 here. Let's adhere to this. Oh, you're running 6.5. We've got to look at here, and we look at every single one of your VMs and make sure they're right sized because heck, I mean, most of us come from ops. I
Yeah.
wasn't completely right sized. In fact, I was one of the most stingiest uh, RAM granters of all time.
Matt,
When I
you? I
realized,
don't believe that. I
I
don't
remember
believe that.
well, I took that active memory number as gospel.
Yeah.
It said, "Oh, you're only using 40 meg.
Yeah.
You get 64 meg then. How about that?"
Right. Right.
And it was only after talking with Ivoxy, and this was prior to my employment with Ivoxy that I realized, no, you want to be between 40 and 60% typically uh, used memory versus what you have granted, so to allow for the spikes
Yeah.
and things like that. But
Yep.
yes, learning the hard way seems to be sometimes the only way.
Well, and you say that we learn things in our lab. There's no better lab than you listeners, our fellow customers, um, to play around with things in. So that's really where we love to see where
Right, of course.
how some of these things manifest themselves, because we're not running an enterprise database cluster, that's getting 15,000 connection requests per
Right.
second in our lab. That's a little difficult to spin up. So yeah, a lot of this that we've learned are things out in the field, doing assessments, right sizing, verifying and validating, and making sure that our hypothesis and our conclusion and our observations all align with each other. Um, and just real quick in closing, a common question that we get on this NUMA thing is, how do I know if I'm experiencing problems related to NUMA scheduling? How do I
Yes.
know if I'm suffering? So the real quick answer
What am I
is,
watching for?
yeah, first thing we're going to see CPU ready increase. And CPU ready is something that we can see in vCenter. And what we're looking for are CPU ready values per vCPU of perfect world 5%, 8% or less. And CPU ready is the amount of time that a virtual machine is waiting to be scheduled. It's not wait time, but it's waiting to be scheduled time, right? It's ready to ride the bus, and it's waiting at the bus stop to get a seat on the CPU bus to go take its ride to work. Now there is another value, since this is invariably going to be a multi-way VM, something called co-stop. And so for any virtual machine that has more than one vCPU, co-stop is a value that you're going to see. Co-stop needs to be 3% or less. If we see, and co-stop is the amount of time that the virtual machine sits also waiting to be scheduled, which is why ready time accrues. But because the hypervisor cannot find the right multi-way configuration, multiple executable physical threads to schedule that virtual machine against, and that's when we know we're having significant problems. Now, it is important.
Yeah, I can't find you 4 consecutive seats for the Seahawks
game.
game. I got
Exactly.
3,
yeah, we're going to the Seahawks game, and or maybe going to the movies, and there are not 4 seats together, and so you're going to sit there and wait to sit down until we can find you 4 seats together, which is another argument for not over provisioning a virtual machine with CPUs when it doesn't need it. And it is important for those of you listeners out there to enable extended vCenter statistics. So in vCenter, going and enabling statistics level 3 is our suggestion for the first 3 monitoring intervals. And if anybody has any questions on how to do that, reach out to us at the address that you'll hear at the end of the podcast, and we'd be happy to walk you through that, or even send you a performance guide related to some of these topics as a PDF. Be more than happy to do that. I would also like to say that it's a bit of a stretch to think that we can go in vCenter and go click around for 6 hours every day to go look at graphs and metrics and comparisons. That is, we will spend the rest of our natural lives doing nothing but that, right? Because vCenter, does not allow us to send alerts out for these kind of things. We don't have any ability to do reporting. There's no predictive analytics to tell us, hey, Steve, in a week, you're going to start having co-stop problems. If you keep up with, adding additional workload, or if your workload characteristics continue to look like this, you're going to have a resource problem. So that's our shameless plug for vRealize Operations, currently in its version 7, that will look at that information, alert us if there are performance issues, tell us what to do to fix it, allow us to remediate the configuration problem right within VROPS, do predictive analytics, what if scenarios, what if I added 5 more virtual machines with these configurations and this workload, what would that do to performance? And future trending to tell us that we're 3 or 4 steps away from walking off the end of the plank and going into the drink. So while we can do this in vCenter, it is not practical and pragmatic for anyone to use a point tool like that to get their, to get their head around performance data configuration best practices. Not even we could do that. It's just too much. It's too much information to
Right.
sort through.
It's too much of a snapshot
Too
point
much.
in time when you have
Yeah.
to you want to look at more of a wider range.
Bingo.
Awesome.
Yeah.
Alec, awesome stuff. I'm really glad you were able to make it to this podcast. I know it's been a long time coming, and I think our listener base was probably about to break down the doors and say, "Where is Alec Taylor?"
Well, we have all
And
these other smart people, right? Like yourself, Mr. Yette. So, like, I'm clearly more the looks of the business.
talk about a face for radio. Right?
Talk about a face for radio. Yeah, right.
That's
exactly.
why they bring me here.
That exactly, indeed. But Matt, for you and all the other consultants that have put together so many fantastic podcasts, which I listen to. They're entertaining and there's terrific information in there. And you would think, oh, I know what these guys have to say, and why would I need to listen to our own podcasts? But again, not only are they always entertaining, I do always take away useful information that I didn't know before. So these things are good to listen to, even if this is where you work and what you do day in, day out. So we really appreciate the time and the expertise that you guys have put into doing these, and these are a whole lot of fun.
Well, I appreciate you saying so, Alec, and it's obviously a pleasure to have you as our technological leader in this, and I'm not just saying that because I have to.
Right. But it doesn't, it doesn't hurt. It's not going to hurt.
Exactly. Well, thanks everybody for listening to Data Center Therapy, yet another episode here. We will be back here shortly with another episode. Looking forward to future episodes of Mr. Taylor, because as I look at our punch list, we are like 50% accomplished on what we had in mind to talk about today. So plenty more to follow up on. If you want to reach out to us, we are at ivoxy.com. You can email us if you've got topics you want to hear us chat about at podcast@ivoxy.com. That's that aforementioned email address if you have anything you want to reach out to us about in relation to the podcast or anything really. So once again, Mr. Taylor, thank you for joining us. I am Matt Yette. Thanks for listening to Data Center Therapy. Have a great day.